See those corners? They are a lie. This wave looks sharp, mechanical, digital, but hidden inside it, there are no corners at all. Only perfectly smooth waves. Stack enough of them, and corners appear out of nowhere. This is the Fourier series, and it may be the most useful idea mathematics has ever produced. Start with the simplest wave there is, a sine wave, one frequency, perfectly pure. If you could hear it, it would be a single clean tone, a tuning fork, nothing more. On its own, it is smooth, predictable, and honestly, a little boring. But watch what happens when it gets company. Take a second wave, 3 times the frequency, 1/3 the height. Add them together, point by point. The peaks flatten, the sides steepen, add a third wave. 5 times the frequency, 1/5 the height, flatter still. Then 7 times. Then 9. Do you see where this is heading? Every wave we add pushes the sum closer to the square. Here it is, with 50 waves. The smooth curves are building corners. With infinitely many, the match is exact, not approximately. Exactly. Here is the entire recipe. 4/pi times sine x plus 1/3 of sine 3x plus 1/5 of sine 5x, and so on forever. Odd frequencies, shrinking heights. That is all a square wave is. But there is a deeper way to see this, because a sine wave is really a circle in disguise. Take a point, moving around a circle at a steady speed, and track its height as time passes. That height traces out a sine wave every single time. A sine wave is just circular motion seen from the side. So if a square wave is a sum of sine waves, then a square wave is also a sum of circles. Put a smaller circle on the rim of the first, and an even smaller one on that. Each circle spins at its own frequency. Now follow the tip. It draws the square wave. Circles stacked on circles. Add more circles, and the corners sharpen forever. And here is Fourier's astonishing claim. See, this works for any repeating signal. Any signal at all. A violin note, a heartbeat, your own voice. Each one is a unique recipe of simple waves. The general formula looks like this. Sum of sines and cosines, each with its own weight. Find the weights, and you have decoded the signal. This is how your music gets compressed. How images shrink into JPEGs. How an MRI sees inside your body. The device you are watching this on is running Fourier's idea thousands of times every second. Joseph Fourier published this in 1822. The greatest mathematicians of his time did not believe him. How could something jagged and broken be made of things perfectly smooth? But he was right. Complexity is just simplicity added up. Circles hiding inside everything. Once you see them, you will never stop seeing them.